Hello guys, in this video I'm going to show you a template I've created to solve backtracking problems. Okay, so in backtracking problem the main thing is to write the code to simulate this recursion tree. By recursion tree I mean this type of tree. Okay, so this is the template I've created. So if you look closer you will see it has basically how many steps? Okay, so it has basically four steps. First step is the base case. So base case is the case where we want to terminate a branch. Okay, so either we found the solution, we want to terminate the branch, we don't. That's the base case. Like the case where we want to terminate the branch by finding the solution. Okay, simply that. And choices are the choices are those conditions for which we will create a node. So let's say in this case we have one choice this, so this is a node. Second choice is this is a node. So these are the choices. Okay, and third step is the constraint. So in the choices also, when we make a choice, we will we will be faced with a constraint. Okay, so let's say we make a choice. Now is this choice valid? So that's a constraint. Okay, and then the backtracking step, basically going back a level up in the tree. Okay, you'll understand once I show you the code. Okay, so let's take an example of this problem. This is a very common problem, and it deals with subset. Okay, let me just close this so I can zoom it a bit more. Okay, okay. Now, what is the problem? So the problem is we want to find all the subsets for this, for the given array. In this case, the given array is this 1 2 3. Okay, so what are the subsets of 1 2 3? It's this 1 2 3 1 2 1 3 2 3 and 1 2 3 and an empty set, because empty set is a subset of every set. Okay, so how are we creating this tree? Okay, so let's say so basically we are creating this tree through code. So I'll go through the code and tell you at each step what part of tree are we creating. Okay, okay. So first step, we have to create a result empty array, because that's what we want to return, and this is the main meat of the algorithm, the backtrack function. Okay, so in this function we'll first write the first step, which is the base case. uh, okay, these are the steps. I put a numbering in the comment also for better understanding. Okay, so now for the first step we'll write the base case. So what is the base case? Base case is this, when we explode all the numbers, we those so after exploring all the numbers, the result will be our answer. For example, uh, at first step we are making a choice for 1. Do we want to add 1? uh, like the choice is to add 1 or not to add 1. So this was our empty set. First choice is we add 1, second choice we didn't add 1. Okay, then we move to second index 2, and now we will choose to add 2 or not to add 2. So this was our set. So in 1 we added 2, we haven't added 2, we move. Okay, now here we added 2, we not added 2. Okay, then we move to the last index, which is 3. Now our choice is to add 3 or not to add 3. Okay, so in 1 2 we added 3, we not added 3, we added 3, we've not added 3, we've added 3, we've not added 3, we've added 3, we've not added 3. So no more choices we have, no more indexes left. So basically that this is our answer. So this is our base case if index is the last number. Okay, now now we have to write our choices. So in this case we have two choices, either to add the current index. Let's say in the first step we were making choice for first index, which is 1. Either we can add 1 or not add 1. So our choice would be to maybe our first choice is to add the index, and second choice would be to not to add index. Okay, so this is our first choice, include num index, which is the first number, let's say. So path path is that the answer we got from the above level. Okay, in this case this was empty, path is empty. So either we can add 1 to this empty set. Okay, so path dot append num index, we've added 1. Okay, and okay, so this is our first condition, we added 1. Now in order to go to second condition, we first go back to the upper level, then we can go down to the second option, second choice. Okay, so then we did the backtrack. We went sorry, so basically after appending we added 1, and then by calling backtrack we continue the algorithm. After adding 1 we continued the algorithm, so that's what this line means. Okay, we added 1 and we continued making this tree, this part of the tree. Okay, so we added 1, we continued uh, creating this tree. Uh, then we added 1, we continued this tree. Now to create this part of the tree, we have to add 1 and then create the tree and then go back here. Okay, so then we went back by popping 1 again. So okay, so we come to this, we continue here, and then we go back to this, and then we have to come here. So so come here. So here we added 1 to get here. Now here we haven't added anything. Path equals to path basically. So path equals to path. So this was path, this is path. So path equals to path. We come here. Now we came here and we have to continue this tree. So we called again backtrack. So basically this is how this tree got created. Okay. So that's how we created this recursion tree for this problem. Now let's say, so this is the first type of problem where we have like binary tree type of structure. We have only two childs per node. But there is one more type of recursion tree I've seen in the problem is this one. So this is the second type of recursion tree I've seen in the problem is this one. In this you see we have not true two branches like the one above here, like the binary tree like this, but it has multiple branches. So this is the second type of recursion tree I've seen. So in this you are seeing each node is kind of having three children, and it can have more children. It is three because it based on the number of elements there in the array. So this is the second type of recursion tree. So let me walk you through how we are building this recursion tree is. So basically we want to create all the so this is a permutation problem. Okay, in this we want to create all the permutation for this given number. So how many permutation would be there for this these number 1 to 3 would be 3 factorial. Three numbers 3 factorial. So 3 factorial is 6. So there would be total of 6 permutation for this number. So one would be like 1 2 3 1 3 2 2 1 3 3 2 3 1 3 1 2 and 3 2 1. These are total how many? 1 2 3 4 5 6. So total 6 permutations we will get. Okay, so let me walk you through how I am creating this tree is I'm adding uh, this number in each branch for the parent path or node. So let's say we start with an empty set, then first we added 1, then went back, then added 2, went back, then added 3. Same thing we did for 1. For 1 we added one more 1, so 1 1, then went back, then add 2 1 2, then went back, then 3 1 3. Same thing I did for this. So 1 2 I added 1, so 1 2 1, went back, added 2 1 2 2, went back, added 3 1 2 3. So that's how I am creating this tree. Okay, and I'm adding this until I'm getting uh, a node with the length of 3, which is same as what we are given in the num. So this has 3 length, this has 3 length. So I'm creating the node, and I'm like exploring the tree until I'm getting the 3 length node. Okay, so how the code will look like for this is like this. So same template we'll use. So first we'll write our base case. Number one thing to do, what would be our base case? The path, the node length should be equal to the nums. So path is basically are these nodes. Okay, so these are the base case. If we find this, we'll append a copy of the path to the result. We are appending copy because path is a reference. It will get modified like again and again. So we don't want to update the values of the result. So that's why I'm doing a copy. Okay, okay. Now how? So second thing is our choices. So to create the node, what is our choice? Is our choice is to add each element. So this is our first choice, to add the 1, second choice is to add 2, third choice is to add 3. So these are our choices. Okay, okay. So because in previous case, if you see, our choice is to either add 1 or skip 1. So these are the choices. That's why it has only two branches. Either we add 1 or remove 1. But here we are adding each element. We are making choice on each element, and choices we are adding it. So okay. So that's why there are multiple branches. If we had like 1 2 3 4, there would be like 1 2 3 and 4 branches would be there. Okay. So this is the second type of recursion tree. Okay, so okay, so for num we are iterating over numbers, and then we are appending it to the path. Okay, node, we are adding it, then calling backtrack basically we are adding one and then calling backtrack to create this subtree. Okay, and then we are going back by doing pop, and then again we added 2 in the next loop, again we added 2, called backtrack, then went back, then again add 3, call backtrack, went back. So that is, so this is the for loop, and that's how we are creating this recursion tree. Now one line is pending is this constraint. In the last problem constraint was not there, but in this problem constraint is there. So in the last problem there is only first step, second choices, and what 4 backtrack step, take this here, this one fourth backtrack. But this third constraint part was not there in the last problem, but here it is. That's why I'm showing you this problem also. So what is constraint is, basically constraint is when we want to stop exploring the child branch, or so remember we are making choices. So we made choice to add 1, but is is 1 like, let's say we made a choice to add 1 in this subset, so we added 1 and we found, is it worth exploring child branch for this node? So that is our constraint. So here our constraint is the permutation cannot have a repeating number. So 1 1 is not a permutation of of this branch, and if we explore this, the resultant branches will also not be a permutation of this. So this is our constraint. The number should not be repeating, hence we cannot add same number again. So this is our constraint. If the current number is already in current number, which is 1, we are making decision for 1, we want to add it. So if the current number is already in path, so we don't want to continue. So basically we will not, we call continue, will not append that one. uh, Basically this decision for num equals to 1 is happening at this stage. So inside for loop, so when we check for num, basically we are checking for 1, do we want to add 1 in this. So when we check do we want to add 1 in this, we check if 1 is already there. In case it is already there, so we say continue and we don't create this node. That's why I crossed it. So we will not create this node. hence this entire loop will cancel, so this part will never happen. Okay, similarly, let's say in the next iteration we check for 2. Do we want to add 2? So we this gets this will return false this if, and we'll continue and we'll append 2. So we'll appended 2 here, and then we did the backtrack, like call the and create the child tree, and then we get did the pop, went back, and then same thing. Okay, so this constraint basically happening here in at this stage. Okay, but let's say after creating the child, here I want to check something I want to check. So if you want to check here something, you will write your constraint condition here outside the for loop. So so first so first this constraint will trigger, then after triggering this constraint for the child node, then this constraint will trigger anything you write here, this constraint. So first this constraint will trigger, then for the child node this constraint will trigger. Basically in this constraint we are checking, do we want to create the child node? Okay, but here we already created the child node. We are checking, do we want to explore the childs of this child node? So this is the difference in putting the constraint here and outside the for loop. So so I'll show you an example also for this two constraint. If you put here or put here in the next video, maybe yeah, in the next video I'll show you the difference if you put here and here. This video is already long, so I hope you like this video, and if you follow this template, I think most of your backtracking problem you can solve using this template. So thank you for watching, and I'll see you in the next video. Bye bye.